Hello and welcome to this lesson on Applied Artificial Intelligence Methodology. Deploying and training a machine learning model involves key steps: cleaning data, selecting a model based on constraint, and preventing overfitting using strategies like data augmentation. Model offline evaluation assesses performance and generalization using a separate dataset. After that, it's needed to deploy the model for end user, which involves an engineering challenge ensuring availability and addressing issues promptly. Finally, optimization techniques like model compression are applied to overcome hardware limitation without compromising performance. After completing the task of cleaning and processing the dataset to train a learning model, it is necessary to develop or configure a model and train it to address the posed problem. The first step is to determine which machine learning model we are going to use. This model selection task has some constraints: the hardware resources and the training time. To solve a problem, the main goal is to find solutions that address that problem. We can start with simpler and less expensive and as a baseline. Besides, it's advisable to experiment with different features and hyperparameters to find the best configuration for a machine learning model. When a model trains, it may get too good at the training data, but struggle with new data. This is overfitting. To prevent it, we can apply several strategies: data augmentation to increase the training data with perturbations, regularization, and early stopping to halt the training before the validation accuracy degrades. The goal of model offline evaluation is to assess the performance of a machine learning model and its ability to generalize to new data. For this task, we use a separate dataset, known as test dataset, that is not used for training. The idea is to compare the prediction over this separate set with the actual labels to calculate several evaluation metrics. This technique is useful to measure model performance before implementing it in a live environment and helps to identify overfitting or underfitting problems, which can be useful for improving model performance. Ensemble learning is a technique that can enhance the performance of a simple trained model on the test set. There are three types: bagging, boosting, and stacking. Deploying a machine learning model means making it accessible to end user in a production environment. This can be done by incorporating the model's prediction function into a web page and deploying it to a cloud service. This task is an engineering challenge, since we need to make sure the model is available to millions of users with minimal delays and high reliability. When deploying a machine learning model, it is needed to choose between online or batch prediction methods. Online predictions generates prediction in real time with incoming requests, while batch prediction generates prediction periodically, storing them in a database. Alternatively, we need to decide whether to perform computation in the cloud or at the edge. Cloud computing utilizes large servers in the cloud, whereas edge computing involves running computations on consumers' devices. In many instances, it's necessary to optimize model to accommodate hardware constraints. Model compression in machine learning aims to decrease the size of model without significantly impacting their performance. you.